All right, welcome everybody, and this is a new series that I'm coming up with, wherein we will talk about FreeRToS, especially on our ESP32 microcontroller, and we'll try to cover up all the important basics of how to get started with FreeRToS on ESP32 using ESP-IDF as a platform, and we'll also try to cover some intermediate advanced topics as we progress further in this particular series. So I'm thinking to keep this one an unfiltered series, so there won't be much editing and be just straightforward to the point. So FreeRTOS, you might have heard it or might not have heard it, but this one's a real-time operating system, and this is specially designed for smaller footprint devices like microcontrollers and microprocessors. And if you go on the GitHub page, it mostly comprises of C libraries, right? And so this one is like, if you have a single core, like we do in most microcontrollers, this one try to mimics an operating system like behavior. Since we have dual core on ESP32, so here they have already stated that they have worked and modified the vanilla FreeRTOS to support SMP. Now, what is SMP? Well, you can see SMP is symmetric multiprocessing. What does it mean? So in this, what happens is that multiple cores this share a common resource, basically memory and all the IO devices. So basically, because we have two cores in ESP32, all the peripherals and the main memory, they are shared among these cores. So you can read about this stuff. Also, one thing that is important, they've already stated that in vanilla FreeRTOS, we used to change this file, FreeRTOS config.h header file, in accordance to what we want, whatever configuration we want. But in ESP-IDF, we don't need to do that. We already have that idf.py menu config option, wherein we should change whatever configuration we want to change, and not directly go and change these files in the component. So I have VS Code open with me here. Let me show you guys. So we have VS Code. Let me create a new project, and this will be a common project throughout the series. What should I name it? Yes. So after we create a project, this is what we get, the emptiness. So let's start. All right. Couple of headers need to be included for FreeRTOS, task and main. So let me start with the simple API, xTaskCreate. The first would be the task function. Let us create a task function that would be executed. So let's call it task A. And this would be the set of parameters for this particular task. We'll talk about it in a while. So I've created that. Let us add that task function here. Next would be a string for this task. Don't worry, you can put anything up here. Later there would be a third one, which would be stack size, but remember this would be in bytes, unlike the number of words or the size of task stack in words. In case of our vanilla FreeRTOS, ESP-IDF has in bytes. So after that, let me put some random. Now, how to select this? Well, it's just guesstimate, I guess, for now. Then comes param. For now, I'll give it null. Priority, let's give it 1, and then handle, task handle. So when you come in a task, each task is if you have worked with Arduino, it's like void loop. wherein for the infinite while this particular loop should continue. Obviously, if there is an issue, it won't. Let us just give a small print statement and hello from task A. All right. To implement this log I need another header function. That would be ESP log G. Okay, cool. I'll need to declare what tag is. This one is FreeRToS. Okay, let's try to build this. All right, I'll now flash it to my ESP32. Let's switch to monitoring state. Hello from task A. All right. Well, there was some issue. Let me stop it up and just have a look what that issue was. Okay, so what we have here, task watchdog got triggered. Following task users did not reset their watchdog in time. Idle 0 on CPU. What is this? Let me show you. So ESP-IDF, basically one thing that you would have noticed, we didn't call vtask start scheduler as in that we do in vanilla FreeRToS. That's because when we call this function, automatically all of that is, adjusted by ESP-IDF. So these are the list of tasks that start on the beginning. Main task. This one simply when we call appmain, this is called, and when we return from appmain, this particular task is deleted. Then we have idle tasks running on CPU 0 and CPU 1. So basically these idle tasks are pinned to each core of ESP32. Then we have something known as IPC tasks. I won't go into depth in that. So you know now that we have an idle task running on CPU 0. We have an idle task running on CPU 0. We have an idle task running on CPU 1 as well. And we have task A running on CPU. Alright, I'll add some delay. Let's say for 1 second to let this program breathe. So that was simply put basic xTaskCreate. Now let's try to add a param. Let's say I want to add a number. Let's say it's 100. Let's say this. Now what I will do is, since this is a void pointer parameter, let me show you the API. So here it is. We have void pointer. So just typecast and then number. Here we will do is dereference this pointer after typecasting as to int. So we have typecasted it to int and dereference it. Let me again run this. This time let me include flash. Time to burn it in the ESP. There we are with 1 second delay. Starting scheduler on CPU 0, starting scheduler on CPU 1. You can see that, right? Message app start anyway. So this is from FreeRToS ESP32. Hello from task A with 100 plus subs, whatever. Let me exit. So this was basic xTaskCreate API. I have not covered task handle right now, not covered task priority, not covered plenty of things, and we'll cover that as we progress in this series. So hang on tight. Don't forget to like and share this video. signing off.